Now, a histogram is a bar graph that shows data in intervals. It is used to show continuous data. Since the data is shown in intervals, there is no space between the bars. So here's an example of a histogram. It's of test grades going by the frequency of the grade. Frequency tables and histograms both show data in intervals, so we can go directly from one to the other. So here is the frequency table of test grades that we were using in a previous example. We can use this to make a histogram. So the interval that's in the left column is going to now be the x-axis, or down at the bottom of our histogram, and the frequency, which is in the right column, is going to be our y-axis, or on the side of our histogram. We then have our title still of test grades at the top. So now our frequency becomes the bar that comes up from the interval. So for example, we have one frequency, or a frequency of 1 for the grade of the interval of 30 to 39. So I find 30 to 39 on that x-axis, and I'm going to draw a bar up to a y value of 1. So that's what I would fill in, and that would represent the frequency at that interval, but as a histogram. And I would continue to do that for every interval that has a frequency. So for 40 to 49, 50 to 59, they both have a frequency of 0. So you're not going to see a bar on the histogram. But for 60 to 69, we do have an interval of 1. So again, I'm going to draw a bar for 60 to 69. And then now for 70 to 79, I have a frequency of 4. So now I'm going to draw all the way up to 4 over the interval of 70 to 79. Now notice I'm leaving no spaces in between the 60 to 69 interval bar and the 70 to 79 interval bar. They're right next to each other. There's no space because this is continuous data. And then I'd continue, I'd draw an 8 bar for 80 to 89, that interval, and a bar of height 3 for the 90 to 99 interval. So your histogram ends up looking like this. Again, you have the bars representing the frequency for each interval on the bottom of your x-axis. Going up that bar is the height of the frequency from the y-axis, and then the bars don't have any space in between them. We can then analyze the graph of the histogram, and we can answer questions. For example, we can answer how many students scored 90 and above. So you want to find that interval and look at the frequency bar, see how high it is. Same thing for how many students scored between 80 to 89. Well, we can see we have 3 students scored 90 and above because in the interval of 90 to 99, it is ending here, our bar has that height of 3. Similarly, how many students scored between 80 to 89? Well, we have 8 because that interval down here, that bar goes up here to a height of 8. So we're using the height of the bars in the histogram to answer questions about the frequency over certain intervals. It's very easy to see that in a histogram because you can use the height of the bars as how many data points are in that interval. Now again, a histogram is different than a regular bar graph. So here we have our histogram, and then we have a regular bar graph. So look at the two. Think about how the histogram and the bar graph are alike. Think about how they are different. Why are there no spaces in the histogram, but there are spaces in the bar graph? And then what would be the benefit of using one graph over the other? What would the given data tell you to use, the bar graph or a histogram? Does the given data have any effect at all? These are all great questions to think about how to compare and contrast the two graphs. So both graphs, a similarity is that they're comparing data in different categories and they're using bars to show the amounts. But histograms show data in intervals, where the height of the bar shows the frequency in the interval and there are no spaces between the bars. Bar graphs show a specific value for a specific category and have a space between the bars to separate the categories because that data is not continuous. So there is a difference between the histogram and a bar graph, even though they are both using the bars. Another thing to note about the histogram is that sometimes you have an outlier. So notice in our example with the test grades, notice that the test scores are closely grouped together except for one. You have all of these from the interval of 60 to 99, but you have this one bar over here all the way kind of more to the left. It's spaced out more. So in statistics, when a value is much different than the rest of the data set, that is called an outlier. So that bar in that interval of 30 to 39, that one data point is going to be an outlier because in the histogram, it's so much far away than the other bars. So that's how you can tell. So let's get more practice. Here we now have different test scores. So we want to practice and see creating a frequency table and a histogram for this data. So what information would you start with? And first of all, which one should you make first? Should we first make a frequency table and then a histogram and then a frequency table? Does it matter? And then what would be the steps to make them? So it actually doesn't matter which one you make first, but it's a little bit easier to make a frequency table first because the histogram comes very nicely from the frequency table because the histogram, the x-axis, you have to create your intervals, and then the frequency is going to be how tall your bars should be. So it's almost like you create a frequency table when you're trying to make a histogram. So we're going to make the frequency table first. And the first thing we need is the intervals that are going to go in that left column for the grade. So we need to calculate the range of the data. So we need the maximum and minimum value. So we have a maximum of 95 and a minimum of 40. Their difference is then 55. So the scale we'll use for the interval, we'll take that range of 55 and we'll divide. We have 6 rows here, so we want to divide that into 6, which gives us approximately 9.167. So we'll round up, make life a little bit easier for ourselves, and we'll do a scale of 10. So if our lowest score is 40, let's start with 40. So then that first interval would be 40 to 49, and then 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. So then we have to tally how many data points, how many test scores happen within those intervals so we can create our frequencies. So we're going to go through each data point and tally up and see how many data points happen between 40 to 49, how many happen between 50 to 59, and so on and so forth, and then we'll count up our tallies to make the frequency column. So there's 2 data points in 40 to 49 interval, 3 in the 50 to 59, 2 in the 60 to 69, 1 in the 70 to 79, 7 in the 80 to 89, and 2 back in the 90 to 99. So that's our frequency table. Now we can use this frequency table to make the histogram. The grade is going to be on the x-axis, those intervals, and the frequency is going to be on the y-axis. So that way, once that is labeled, we can then draw in our bars to make the histogram. So here is our histogram completed. We have the intervals along the x-axis, the frequency along the y-axis, and our different bars showing the test scores, the frequency that are happening in that interval. So here we have our histogram. We have our frequency table and our histogram for the following data. Now, even though it's convenient, we don't always have to make a frequency table. Now, here in this question, it says the table is showing the ages of 20 visitors at a library, and it tells us to create a histogram that represents the data. And what's nice is we're getting the format of the histogram. We're getting the intervals already. We're getting even the scale of the intervals of how high it will be, how high the bars will be, the number of visitors. We're getting a 0, 1, 2, 3, 4, 5, 6. So we just have to take and find out the frequency of how many data points are happening in the intervals that are going along the x-axis, and we can automatically draw that height of the bar. So for example, the first interval is from 0 to 9. So let's circle all of the data points we have from 0 to 9. So we have 1, 2, 3, 4. So we have 4 data points from 0 to 9. So instead of tallying, instead of putting that in a frequency table, we're just going to draw a bar over 0 to 9 that has a height of 4. And then we'll do the same for 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59 to create that histogram. So here we have our finished histogram. We had 4 data points for 0 to 9 interval, 6 for 10 to 19, 3 for 20 to 29, 2 for 30 to 39, 1 to 40 to 49, and 4 again for 50 to 59. So frequency tables, histograms, it's all about showing that continuous data and showing how many times the data points happen within an interval. It's that kind of data display that shows your information with that frequency and how you can see the numbers as a whole.